Hey Chemistry, Mrs. KJ here, going over the gas laws lab. Gas laws involving pressure, temperature, and volume can be examined by performing some simple but elegant procedures. How do quantities of gases change with changing amounts, pressures, temperatures, and volumes? Balloons are containers of gas that you will use to explore such questions. Specifically, you will look at how the volume of a gas changes with temperature. All right, so since we're going to focus on volume, we want to make sure we know the definition of volume. Volume is how much space something takes up. It is not how much stuff you have. It's how much space it takes up. Okay, so you got to be careful on that. I don't want to know how many molecules or moles of a gas I have. I want to know how much space it takes up, and we measure that space in liters. For example, if you go to the grocery store, you can buy a liter of pop or a 2 liter bottle of pop. And so you just kind of have an idea in your head about how big 2 liters is. And that's how much space the pop is taking up. We don't care how many molecules of pop you have. We just care how much space it's taking up. So that's what we're focusing on. Except instead of pop, we're going to use gases. Goals for the lesson: determine how a change in temperature affects the volume of the gas. Determine values for quantities such as temperature, pressure, and volume for a gas liberated in a chemical reaction. Many variables affect the size of a balloon. Balloons can be used to demonstrate the behaviors of gases. Long before they knew details about atoms, scientists described the behaviors of gases. Some key scientists were motivated by the invention of the hot air balloon. Because think about it, back then they didn't have cars and airplanes, so a hot air balloon being able to transport you was super cool. Balloons contain gases such as the mixture we call air, and some of them contain helium. The gases inside exhibit certain behaviors that you can measure. In this lesson, you will learn about the behaviors of gases by experimenting with balloons. Specifically, you will explore the effects of temperature and the amount of gas on the size or volume of the balloon. So we're going to change the temperature, and we're going to change how much gas we have, and we're going to see how much that impacts the amount of space the balloon takes up. Because volume will be a key measurement in this activity, take some time to review how to measure it. All right, we're going to get to that. We'll get to that review in a little bit. Create and capture a gas. Actually, we'll come back to that part. Let's do this part first. So, we are going to heat a balloon. All right, so here is our lab. I'm going to take a balloon, and I'm just pumping it full of air. And I'm using air that's in the vertical room. And so since I use the air that's in the room, the air inside the balloon is the same temperature as the room. And we have a thermometer right there. So we can see that the temperature of the room is 19.2 degrees Celsius. And we can see that the temperature of the air inside the balloon would be the same. All right, so we need to write that down. Initial temperature of air in the balloon, 19.2, and we already know it's degrees Celsius. So now we're going to measure how big the balloon is, and we're going to use calipers. That's this measuring device. Calipers is used a lot in electricity if you're an electrician, but other than that, we don't use calipers a lot in real life. All right, so let's take a look at our scale that we have down here. So let's go ahead and look at how the calipers are measured. We notice that the unit is cm, so that stands for centimeters, and this would be 1 centimeter, 2 centimeters, 3 centimeters. We can also see that they have these little lines, and each of these lines represents how much? A half. So if it was right to here, my distance would be 3.5. Okay. Now they do have tiny little lines marking 0.1, 0.2, 0.3, 0.4, obviously 0.5, 0.6, 0.7, 0.8, 0.9, and then 4, but those are kind of hard to see, so we're going to have to do some estimating. But we can do a decent amount of estimating by using just the half lines and the whole lines. So, all right, so here's how far apart the calipers are, and we're going to measure that distance down here, right where that little green arrow is. So it's right there. And if it was right here, it would be 14. 15 would be over there. So we know it's between 14 and 15. this line right here is how much? 14.5. And so we know our answer is somewhere between 14.5 and 15. We could say 14.7 or 14.8. Really, it's just somewhere in between there. So let's go with, let's do 14.7. There we go. All right. And then we're going to find the diameter of the balloon after heating it up. And we're going to put it in warm water. So let's go back to the lab. And we have our water here, which hopefully is heating up. And let's take the temperature of the water. And what's the temperature of our water? It's exactly 50 degrees Celsius. So the water temperature is 50 degrees Celsius. Now let's think about what's going to happen. We are going to put the balloon in here, maybe, if it lets me. I think I have to take my thermometer out first. We're going to put the balloon in there. We're going to put the cover on and start the timer. Okay, so right now the water is 50 degrees. The air inside the balloon is 19 degrees. What's going to happen to the air inside of the balloon? Is the warm water going to make it heat up, stay the same, or get colder? Well, the heat of the molecules, which is really just the fact that the molecules are bouncing around like crazy, are going to hit the molecules of the balloon, which hit the molecules of air inside the balloon, causing them to go faster too. So if the molecules are going faster, the temperature is going to be warmer. In fact, we're going to keep it in here for 4 minutes, and after 4 minutes, the temperature inside the balloon is going to be the same as the temperature of the water. So if I could stick a thermometer inside the balloon, after 4 minutes, the thermometer inside the balloon would also say 50 degrees. So we're warming up the balloon. So if we're warming up the balloon, what do you think is going to happen? Is it going to get bigger, smaller, or stay the same? Well, the molecules are moving faster and harder, so they're going to push on that balloon, and they're going to spread out the balloon or make it bigger. The way that I like to remember this one is think about yourself when you go outside and if it's hot or cold. So if you go outside and it's 30 below zero, what does your body naturally do? You huddle up, right? You get as small as you can to conserve your body heat, and your volume got smaller. So when the temperature goes down, the volume gets smaller. But when it's hot outside, we're going to spread out on the beach. Doesn't that sound good? And you spread out because it's hot outside. So gases do the same thing. When they're cold, the temperature decreases, the volume decreases, and they come close together. When it's hot, the molecules move faster, they spread out, the volume increases when the temperature increases. All right, so our timer went off, and that means that our balloon had enough time to heat up from the water. And so we're going to measure it, and let's check back what it was originally. Originally, it was 14.7 centimeters across. So let's go ahead and measure it now. And what would you say it is now? Well, I'd say it's more than 15, less than 16. Is it at 15 and a half? Not quite. So it's between 15 and 15 and a half. So I would say it's about 15.3. So does our data show that the balloon got bigger after we heated it? Yeah, it does. So as this showed with balloons and gases, when it gets hotter, it expands. All right, so now we're going to do the second part of the lab, and we're going to take a balloon and we're going to put it in here, and what do you think we're going to do? We're going to cool it off. So I'm putting up the balloon. What would the temperature inside this balloon be? It would be the same as the temperature of the air in the room. And what's the temperature of the air in the room right now? 19.2 degrees Celsius. So let's fill that in. We have our initial temperature of the balloon, 19.2 degrees Celsius. And let's measure it. And what would you say the diameter or the distance across the balloon would be? I think it's right at 15. So since it's exactly 15 and I want my answer to tenths, what number do I put after the zero? Oops, after the decimal. Shoot, I said it. I would put a zero after the decimal, right? 15.0 to show that it's exactly 15. All right, so now we are going to, we gotta get the temperature inside the container so we know how cold it is. And what's the temperature of our water in this case? It is 5.0 degrees Celsius. And we are going to go ahead and put that in for, I take the thermometer out first. We're going to go ahead and put that in. And what do you think is going to happen to the size of the balloon this time? All right, so let's let it cool down for 4 minutes. And there's a couple of other mathematical items that we need to figure out in the meantime. So the first thing that we need to find is the radius. So we measured the diameter. The diameter is all the way across. The radius is not all the way across. The radius is only halfway across. Okay, so we need to find the radius of the balloon. So if my entire diameter was 14.5, then what would I put in my calculator to find the radius? I put in 14.5 divided by 2. All right, so let's go ahead and look at what we need. Our diameter of the balloon was 15. So what would the radius be? 15 divided by 2 is 7.5 centimeters. And the reason we have to do that is because we're going to find the volume. We're going to find out how much space the entire balloon took up. And to do that, we have to use this equation. Volume equals 4/3 times pi times the radius cubed. So let's break down this equation. So it's volume equals, and you just have to type 4 divided by 3, times pi. If you haven't done pi in math class, pi is a specific number that is used to show the size of circles or spheres. Basically, it's 3.41. So instead of pi, which is different than the pie you eat, it's 3.41. All right, then it's times the radius cubed, which really means the radius times the radius times the radius. So this is everything we have to put into our calculators. So let's go over here, and we're finding how big the balloon is. That's the volume. So in your calculator, you're putting 4 divided by 3 times 3.14 times, how much is the radius of the balloon? 7.5. We gotta do that 3 times because it's cubed. And put that in your calculator, and what do you get for an answer? You should get 1,766.25. Now, if you have used pi in math and you've used the pi button on your calculator, your answer is going to be a little bit different than mine. Okay, so that's why you might have gotten something else if you used the pi button. All right, so we figured out how big it is according to the volume, how much space it takes up. The other information that we need to know is we need to change our degrees Celsius into degrees Kelvin. So to do that, we put it in this equation. So how many degrees Celsius did we start with? 19.2. So 19.2 degrees Celsius plus 273 is going to equal our answer in kelvins. And there you go. What would our answer be? 273 plus 19.2 is 292.2. 292.2 Kelvin. And we don't say degrees Kelvin. I don't know why. We just don't. So that's our answer for that one. All right, let's go ahead and find